Think about it for a second. For almost all of human history, literally anyone could step outside, look up, and just be completely overwhelmed by the staggering beauty of the cosmos. The night sky was this massive canvas of thousands of stars. I mean, the Milky Way was so bright it cast shadows on the ground. It was a profound source of inspiration. But today, well, rapid urbanization is changing all of that. A glowing artificial haze has kind of draped itself over our cities, and a startling number of people living today have never actually seen the Milky Way. But this isn't just a story about losing a pretty view. In today's Explainer, we're diving into a deeply philosophical and scientific question: is the loss of the dark night sky fundamentally changing human curiosity? Are we losing our drive to understand the universe simply because, well, we can no longer see it? Okay, let's dive in. So, the Dark Sky Research Union has launched a real, active citizen science initiative to figure this out. This isn't just some abstract theory sitting in a textbook, it's a global, interactive research project. And the best part? It's one that you can actively participate in. Researchers are trying to quantify the exact correlation between light pollution, night sky visibility, and the resulting impact on human curiosity and cognitive development. It's this incredibly cool merger of astronomy and psychology. By the end of this explainer, you're going to have the exact tools and knowledge you need to step outside tonight and contribute your own data to this vital scientific endeavor. Here's our roadmap for today. First, we'll explore the awe deficit, then unpack the scientific blueprint, understand the Bortle scale, walk through a step-by-step survey guide, and finally, talk about reclaiming the night sky. All right, jumping right into part one, the awe deficit and the psychological toll of a glowing sky. To really get what's at stake here, we have to look past the telescopes and focus on the human mind, specifically the minds of the younger generation. We've got two key concepts to define first. The first is ALAN, which stands for artificial light at night. That's the environmental shift, the drastic reduction in sky visibility because of urban glow. The second is epistemic curiosity. This is a psychological term. It's basically that natural, deep-seated itch to seek out new knowledge, to ask why, and to understand how the universe works. So the central research question this survey asks is pretty profound. Does ALAN cause an awe deficit that actively diminishes our epistemic curiosity? Basically, if a child grows up never seeing the stars, do they just stop asking questions about what lies beyond our world? To actually measure this, the researchers use something called an awe scale within the survey. Take a look at this quote right here. This is an actual item from that scale. Looking at the sky makes me wonder about my place in the universe. Participants rate how much they agree with this statement from 1 to 5. It takes hard, objective data about light pollution and anchors it in raw human emotion. It's measuring what psychologists call dispositional awe, that feeling of vastness that expands your mind. Does a blank, orange city sky literally reduce our capacity for this awe? That's exactly what your survey responses are going to help uncover. Moving on to section 2, the scientific blueprint, where we merge astronomy with psychology. So how on earth do researchers plan to measure something as invisible as curiosity and compare it to something as vast as the night sky? Well, the secret is in their sampling strategy. The study specifically targets school students aged 12 to 16 because that's the absolute critical age for forming a science identity. They divide the data into two primary groups. Group A represents high pollution. Think dense urban city centers, places like Intermurret or Delhi NCR, where the sky is just a washed-out gray or orange. Group B represents lower pollution. These are rural villages or outskirts maybe 40 to 50 kilometers away from the city glow, where the sky is darker and you might actually see the Milky Way. By comparing the curiosity scores of Group A against Group B, researchers can see if there's a baseline difference in STEM engagement that is fundamentally driven by their environment. Now here's where it gets really cool. This data mapping shows just how multidisciplinary this research is. When you submit your survey, your zip or postal code is immediately cross-referenced with real-time VIRRS satellite radiance data. That means they are using actual satellite imagery showing light pollution from space. They combine this objective environmental data with your subjective psychological scoring on Littman's epistemic curiosity scale. Then they run this massive dataset through statistical software like JASP or Jamavi to find the correlations. It is an incredibly rigorous process. They are literally linking a pixel on a satellite map directly to a human being's sense of wonder. Okay, section 3, understanding the Bortle scale. Let's talk about measuring the dark. If we're going to do this study together, you need to know how astronomers actually measure darkness. Enter the Bortle scale. It's a 9-level numeric scale that measures the night sky's brightness at a specific location. It basically quantifies how well you can observe celestial objects and how much interference is caused by light pollution. On the far left of the scale, you have a Class 8 or 9 inner-city sky. That's where only the moon and maybe a few bright planets can even punch through the haze. But on the far right, that's a Class 1 excellent dark sky site, a perfectly pristine view of the cosmos. Your main job in this survey is to figure out exactly where your own backyard falls on this spectrum. To make it super easy, the survey uses a simplified Bortle scale assessment. Let's break it down so you're totally prepared. If you look up and the sky is bright gray or orange, and it literally feels like you're looking through a glowing fog where you can only spot the brightest stars, you're at an 8 or 9. Now, if you see a noticeable orange or white sky glow on the horizon and the Milky Way is totally invisible, you're around a 6 or 7. If the sky is a darker grayish blue and you can just catch a faint trace of the Milky Way, you're in the 4 or 5 rural transition zone. If the sky straight overhead is truly black and the Milky Way has deep, obvious structure, you're at a 2 or 3. And if the Milky Way is so blindingly bright that it literally casts faint shadows on the ground, yeah, for real, congratulations, you're at a Class 1. Which brings us to Section 4, your step-by-step survey guide. Think of this as your citizen science mission. Now that you know the science behind it, it's time to act. Think of this as your personal scientific toolkit for your observation mission tonight. Here is exactly what you need to do. Step 1. Wait for a clear, moonless night. The moon acts as natural light pollution, so we definitely need it out of the way. Step 2, and please don't skip this. Let your eyes adjust to the darkness for at least several minutes. If you just stare at your bright phone and then immediately look up, your pupils haven't dilated yet, and you won't see the fainter stars at all. Step 3, observe the dominant color of the sky glow. Is it orange, white, pink? And then rate your Bortle class using what we just learned. Step 4, estimate the distance to the nearest direct artificial light, like a street lamp, and note down if there's any cloud cover. When you actually open up the form, you're going to see a question about visual acuity control. It asks if you wear corrective lenses for distance vision. Now, you might be wondering, why does that matter? Well, if you have poor vision and you aren't wearing your glasses, you're naturally going to report seeing fewer stars. The researchers might falsely attribute that to light pollution instead of, just your eyesight. So the absolute key here is to just be honest. It ensures the scientific accuracy of the star count is maintained across every single participant. All right, let's talk about a few common mistakes that can completely ruin a dataset. First, ignoring cloud cover. If it's cloudy, the sky looks artificially darker, or sometimes it actually reflects city light and looks brighter. You absolutely must report the weather. Second is ignoring socioeconomic status, or SES. This is huge. City schools might have wealthier students with way more access to science books and museums, which could falsely boost their curiosity scores. The researchers need to compare apples to apples, like comparing a middle-class urban student directly to a middle-class rural student, so they can isolate the effect of just the dark sky. Third, please don't be vague. Use the exact 1 to 9 scales provided on the form. Don't just say, stars are kind of hard to see. And finally, never fake your zip code. The entire study falls apart if they can't match your exact location to the satellite light maps. At the very end of the survey, there's an optional Section 6 where you can actually upload a photo of your sky. But there are some incredibly strict scientific rules for this. You have to place your phone completely flat on a surface, facing straight up toward the zenith. That's the point directly overhead. Make sure your flash is completely off, set the camera to pro or night mode so you get the longest exposure possible. And please, absolutely no Instagram filters, no editing whatsoever. The researchers need the original, unedited image file so they can extract the raw EXF data, things like exposure time, ISO, and aperture. They use all that to scientifically calibrate exactly how bright your sky is. Finally, Section 5, reclaiming the night sky and the future impact of your data. So why are you spending 4 minutes of your evening doing this? What's the actual future impact of all this data? Well, your data doesn't just sit in a random spreadsheet. It fuels a real movement. The DSRU aims to publish these findings in major peer-reviewed journals like Nature Astronomy or the Journal of Environmental Psychology. They're going to use this exact data to conduct generational studies, literally comparing what we see today against the oral histories of what our grandparents used to see. But most importantly, this builds a long-term movement. Having hard data gives advocates the real leverage they need to propose local dark sky reserves, to push for better downward-facing street lighting policies, and to fund educational reforms where schools actually monitor their own light pollution. You are literally providing the ammunition needed to protect the night sky. We've covered a lot of ground today, exploring the profound link between a dark sky and a curious mind. We've seen how a washed-out orange sky might literally be dimming our collective imagination, and we've walked through the exact scientific steps we need to measure it. The universe is out there, just waiting to be understood, but, well, we have to be able to see it first, right? So the ultimate question is, will you step outside tonight, look up, and help measure the stars? Scan the QR code, take the 4 minutes to fill out the survey accurately, and help us preserve humanity's connection with the night sky for all the generations that follow us. Thank you so much for joining me on this explainer, and clear skies to you all.